In this video, I'm going to explain a couple new angle types. It's going to be about 5 new angle types, and they are going to happen because of what's called lines cut by a transversal. It sounds complicated, but really the title isn't all that much. Here's a line. Here's another line. And if I have a third line intersecting or crossing these two lines, that is called a transversal. It's just a fancy word for a line intersecting two or more other lines. So let's label it here. That one right there is called the transversal. If you can locate the transversal, it makes locating the other two lines a little bit easier, and then starting to get your perception of what's going on in the picture. Sometimes this image is going to be flipped, so the lines may be running up and down or vertical rather than the way they look right now, but still same rules apply. If two lines are cut by a transversal, it creates one angle, two angles, three angles, 4 angles, 5, 6, 7, creates a total of 8 different angles. There's going to be a relationship between some of these angles. Some of them are going to be equal. Some of them are going to be supplementary, where the two angles add up to 180. But that's only true if these lines are parallel. We'll get to that in a sec. Let's just locate these new angle types, get their definitions, then we'll talk about their relationships. So real quick, review vertical angles, because they're always helpful. Vertical angles are congruent, right? Vertical angles are angles that are right across from each other. They're diagonal from each other. Seems like they should be called diagonal angles. Anytime you see a V reflected, that's usually a good sign that you have two vertical angles, and they are always equal. The new types of angles we're going to talk about, let's start over here. First one is called a corresponding pair or corresponding angles. Corresponding angles will be congruent if the lines are parallel, but let's just talk about where to find them first. Corresponding angles are angles that are in the same spot but on a different line. So if we have two lines here, let's say this is line L and this is line M, then angle 1 is in the top left corner of these 4, right? It's in the top left of line L. What's in the top left of the other line? Let's look at line M. What's in the top left here? Well, 5 is. So 1 and 5 are in the same spots. They're in the top left corners, but on different lines. And that's what corresponding angles are. Same spot, but a different line. So angles 1 and 5 are corresponding. Let's look in the top right. There's 2 right there. What's in the top right of line M? 6. So angles 2 and 6 are corresponding. Angles 3 and, let's see, bottom left of the top and bottom left of the bottom would be angle 7. And bottom right is angle 4. And what's its corresponding angle? The bottom right of the other line, angle 8. Alright, there's corresponding angles. The next type are alternate interior. Alternate is just a fancy word pretty much for diagonal. Interior means inside. So if you think about these two lines as being bread on a sandwich, let's say, what's inside the sandwich? Well, these angles are inside the two lines, right? They're in between the two lines. So out of 3, 4, 5, and 6, we want the inside angles that are diagonal from each other. So basically you're looking for the ones that are on opposite sides or on different sides of this transversal here. We want the left and the right side Those are the diagonal angles. So let's see. Inside is 3 and 6 is on the other side. They're diagonal from each other. They're on opposite sides of that transversal. They're called alternate interior angles. Angle 3 and angle 6. And the other one would be 4 and 5. They're diagonal and inside. Okay. A couple more different types. We got alternate exterior. So if you remember, alternate means diagonal, but now we're talking about exterior angles, angles that are outside. So we got 1, 2, 7, and 8. They're on the outside of our two parallel lines here, or just two lines really at this point. So the diagonal ones are 1 and 8. They're outside the two lines, and they're diagonal or alternate. 2 and 7 are outside the two lines, and they're diagonal. So angles 2 and angles 7. Those are the alternate exterior angles. We have angles called same side. Same side, and there's two different types. There's an interior same side. So same side interior angles are angles that are going to be on the same side of the transversal. Either they're both on the left or they're both on the right. And interior means inside the two lines. So the angles that are inside the two lines and on the same side. Well, let's talk about the right side first. Inside and on the right side are 4 and 6. Those are same side interior angles. Let's look on the left side of the transversal and inside. 3 and 5 are same side interior angles. Like I said, we got same side exterior angles. So on the same side, but now outside the lines again. So on the left side, the outside angles are 1 and 7. They're on the same side, and they're outside. And then we have angles 2 and 8 that are both on the right side. They're on the same side and outside. So 2 and angles 8. So there we got 5 different types. Corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, and same side exterior angles. And hopefully you still remember these guys, the vertical angles. That'll always help. Alright, I'm going to draw myself a new picture, and we're going to talk about relationships of all these angles. Alright, so this time in my picture, I'm going to make sure that these two lines are exactly parallel. So they will never cross, never intersect. So those two lines are parallel. Let's call them the same thing. Let's call them L and M. And we're going to draw another transversal, a line that intersects the other two lines. That's the transversal. Alright. Let's label our angles again here. 1, 2, 3, 4. It doesn't matter what these angles get numbered. We could give them all kinds of crazy different numbers. We're just calling these numbers their name. We could use letters like we're used to, or numbers just make it a lot easier and a lot quicker to talk about right now. Alright. So if these two lines are parallel, if L is parallel to line M, then the following is true. Only if these are parallel, this is true. Corresponding angles, I'm going to use the shorthand now. Corresponding angles are always equal if these lines are parallel. So angle 1, that measurement of that angle is the exact same as the measurement of angle 5. Angle 3 is corresponding with angle 7. The measurement of 3 is going to be the exact same as the measurement of 7. Okay. Alternate interior angles, there's the shorthand for that, are also equal. So whatever the measurement of angle 3 is, 6 is going to be the exact same measurement. Whatever the measurement of 4 is, 5 is going to have the exact same measurement. Same is true for alternate exterior angles. They're also congruent. So 2 is going to have the same measurement as 7. 1 is going to have the same measurement as 8. And we'll throw vertical angles in there just in case. They're also congruent. So 1 is the same as 4. 3 is the same as 2. 5 is the same as 8. 7 is the same as 6. Those are the angles that are equal or congruent. The next set of angles are supplementary. And it's easy if you remember that same side, those are two S's. Supplementary starts with an S. So same side interior angles are supplementary. Same side exterior angles are supplementary. Any of the same side angles, those are the ones that are supplementary. All the rest are equal out of these types of angles. Okay, so same side supplementary. Try and remember that. So that means that 1 and 7, those are same side exterior. They're going to add up to 180 degrees. Okay. Same side interior, 3 and 5. Those two angles will add up. Their sum will be 180 degrees. Alright, so let's do some examples real quick and try this out. Let's say if angle 1 equals the measurement, if the measurement of angle 1 equals, let's say 108 degrees, then the measurement of angle 5, let's talk about the relationship there. You always look at the two angles that the question is asking about. Think about their relationship. What type of angles are 1 and 5? Well, 1's in the top left corner of line L. 5 is in the top left corner of line M, so they are in the same spot, different line. They're corresponding angles. Think about what the properties of corresponding angles given two parallel lines are. Well, they're congruent, they're equal. So if 1 is 108 degrees, 5 has to be 108 degrees. Alright, let's do another one. If 1 is 108 degrees, still, what's angle 7? Well, let's look at the relationship there between 1 and 7. 1 and 7 are what type of angles? They're same side, exterior angles. So, what's their relationship? Same side, exterior is supplementary. Same side, exterior is supplementary. So if I know this is 108 degrees, then I know that 7 has to be whatever is missing to give me 180 degrees. We could think about it, 108 plus what gives me 180 degrees? Or we could think about it algebraically. So 108 plus x equals 180 degrees, and solve for that missing variable. Solve for what's missing. Subtract 108 from both sides, and you get x equals 180 minus 108. That would be 72 degrees. So 7 is going to be 72 degrees. So this is just a quick overview here. Again, you apply those same steps to all these types of angles. Look for the type of angle it is. Are they corresponding angles? Are they alternate interior angles? Are they alternate exterior angles? Are they vertical angles? If so, then they're equal in their measurement. If you find that their relationship or what type of angles they are same side, whether they're interior or exterior, if they're on the same side, then they are supplementary. That means they add up to 180 degrees. Alright, this is a quick overview of the 5 types of angles created by two parallel lines cut by a transversal. If you ever see this diagram, these are the relationships that happen.